Sometimes, buildings and bridges need to be strengthened. A new promising strengthening technique, the CREatE system, was developed to overcome the inefficiencies of previous techniques. In reinforced concrete beams, the EBR technique has presented the bonding ruptures between the reinforcement and the concrete surface. With the EBR technique, the rupture of the test occurred due to the bonding between the reinforcement and the concrete surface, regardless of the strengthening material, be it stainless steel or FRP composites. On the other hand, the NSEM technique presents a rupture by splitting of the concrete cover in the bottom of the beam. Both EBR and NSEM types of strengthening provoke brittle failures due to the splitting of the concrete cover. This inefficiency of the system generates lack of confidence on the designers. So, they tend to produce a more conservative design of the structural strengthening, which leads to lack of optimization of the applied material. To avoid the premature rupture of the traditional strengthening solutions, a new strengthening system was conceived at Universidade NOVA de Lisboa, the CREatE system, the abbreviation for continuous reinforcement embedded at ends. The CREatE system was designed to be used in different structural elements. The solution is intended to anchor the strengthening reinforcement at the ends of the structural element, with no need to use mechanical devices to fix them. For the construction process, after the shoring of the structure, it is necessary to drill holes in the structural element. These holes require specific diameter, length, and alignment in order to allow the embedding at the ends of the strengthening reinforcement into the structural element. Before anchoring the reinforcement into the structural element, the strengthening reinforcement needs a soft transition curve in order to avoid the stress concentration on the transition curve into the structural element. This transition curve can be performed with the preparation and molding of a transition curve on the substrate or the installation of a prefabricated device which allows the desired transition curve. After the initial preparation and subsequent cleaning of surfaces, it is then possible to apply the bonding agent in the hole and on the contact zone of the strengthening reinforcement with the surface of the structural element, as well as the application of the strengthening reinforcement. This system is under an international patent pending process. Meanwhile, some scientific papers have been published in international journals with the test results proving the validation of the CREatE system. This video shows the research campaign results involving more than 30 beams. The tests were performed at natural scale in reinforced concrete beams under monotonic or cyclic loads. The reinforced concrete T-beams had a cross-section height of 30 cm and a free span of 3 meters. The CREatE system was tested with carbon FRP laminates and stainless steel bars. The first example refers to the reinforced concrete T-beams retrofitted with carbon FRP laminates using the CREatE system. You can see the video of the test and a graph showing the vertical force applied on the beam versus the vertical displacement. In gray you have the previous test curves of the reference beam. In light blue the test curve of the traditional strengthening solutions, EBR, and in dark blue the NSEM. In red you have the test curve of the CREatE system presented in real time, which is compared with the curves of the reference beam in gray, of the EBR in light blue and of the NSEM in dark blue. The results show that the stiffness and the yielding force were clearly incremented. A zoom-in of this area shows a crack open in the concrete beam with more than 5 mm. This reveals an extraordinary performance of the CREatE system because it really avoided the bonding rupture. As shown in the graph, the strength was incremented in 80% and the ductility in 230%. The CREatE system exploited the total capacity of the reinforcement, eliminating the premature rupture observed in other techniques. The second example refers to the reinforced concrete T-beam retrofitted with stainless steel bars using the CREatE system. The curve of the reference beam is presented in gray, whereas the test curve of the EBR technique is in light blue and the curve of the NSEM technique in dark blue. These curves are compared with the test curve of the CREatE system presented in red in real time. The results show that the stiffness and the yielding force were clearly incremented. The strength was incremented in 50% and the ductility in 270%. The CREatE system presents a very good mechanical behavior and an extraordinary performance. With it, The debonding rupture mode was eliminated, the ductility incremented, and the performance of the strengthening bars was totally exploited. The CREatE system opens a wide range of new applications. This system can be applied to different structural elements such as beams and slabs, walls, columns and foundations, arches, and also to different materials: concrete, steel, wood, masonry. As a conclusion, the exceptional features of the CREatE system make it the perfect system for structural strengthening.